Hello all, I am Chaitra R, studying in 5th semester MCA at Maharaja Institute of Technology, Mysore. Today I am going to give a seminar on the topic called Benchmarking of Stochastic Production Planning in a Simulation Testbed from the subject System Simulation and Modeling. To start with the topics, the definition of system simulation, defining the topic, examples of testbed, production planning and its problems, example with test cases. These are the topics covered in this seminar. To define with the system simulation and its terms, the system simulation is a set of techniques that uses computers to imitate the operation of various real-world tasks or the processes through simulation. And to facilitate experimentation and assessments of a system, a model is constructed. Usually, this will be a mathematical model. A physical model represents a system as an actual hardware, whereas a mathematical model represents the system as a computational or logical association. In general, systems are modeled as it having a number of inputs x1, x2, x3 and so on up to xn, and having a number of outputs y1, y2, y3 and so on up to yn, and a number of system parameters p1, p2, p3 and so on up to pn. Then a system is often viewed as a function that produces the output y from the inputs x and system parameter p, that is y equal to function of x comma p. The example of this we can give as weather forecasting. For this system, the system parameter may be a sliding window protocol. Next is the defining the topic. First one is the benchmarking. Benchmarking is a process of measuring key business metrics and practices and comparing them within the business areas or against a computer industry peers. This will be related to industry peers, whereas when we come to the exact simulation based topic, the benchmark can be defined as something whose quality or quantity is known and which can therefore be used as a standard with which other things can be compared. The example is a truck industry is a benchmark for the economy. Next is the stochastic. The simulation of a system that has a variable that can change stochastically or randomly with individual probabilities. Stochastic in the sense it is random in nature. Next is the simulation testbed. A simulation testbed is a graphical environment for simulation and rapid prototyping of distributed network systems and protocols. Usually, a simulation is also a platform for conducting rigorous, transparent and replicable testing of scientific theories, computational tools and new technologies. Examples of testbeds are aviation. In aviation, testbed is primarily associated with testing of aircraft engines. And space, testbeds are used to test rocket engines and a variety of components. And in agriculture, the testbed is used for soil testing. Next is production planning and its problems. The definition of production planning is, it is the future of production. It can help in efficient manufacturing or setting up of a production site. The major problem involved in this are indefiniteness in releasing the product into production. That is, the major problem is to determine when to release products into production to meet forecasted requirements. For example, we can take the production of COVID-19 vaccine. The vaccine is produced in a certain amount of time and the number of doses to be produced by the labs changes with time. That is, random number of doses are produced. But the final result should be that will it meet the forecasted requirements. Let's see the test cases. Here the case 1, vaccines produced during the peak time of virus spread. Say about 1 lakh doses is produced and estimated reach is 70k. Next is the case 2, where vaccine produced during the medium spread of virus. Say about 2 lakh doses are produced and estimated reach is 1.5 lakhs. And in a case 3, vaccines produced during less than 5% of virus spread. Say about 4 lakh doses are produced and estimated reach is 3.5 lakh. Why in case 1 the number of vaccine doses produced is less? Because it is the initial stage and it will be a testing stage also. So that is why the vaccine produced by the labs will be less in that time. Now we can see in this table the peak, whereas it contains period, produced vaccine doses, estimated reach and actual reach. Here we can see whatever the test cases we have written here, the same data we have produced in this table, but with the actual reach data also. So for 1 lakh doses, when 1 lakh doses are produced, the estimated reach is 70k, but the actual reach is 60 to 65k. And when 2 lakh doses are produced during medium spread, estimated reach is 1.5 lakhs, but actual reach is 90k to 1 lakh. And when the period that is when there is less than 5% of virus spread rate, the production of vaccine doses is 4 lakhs, and the estimation done by them is 3.5 lakhs of reach, but the actual reach is 2.5 to 3 lakhs. Here we can see that the manufacturing of vaccine is stochastic in nature. That is, we can see that in the produced vaccine doses column, when the time changes, the number of vaccines produced also changes. And we know the quantity of the products produced in prior, and before leaving it to the people, or before introducing it for the people, we know how many doses of vaccines are produced. And therefore, by the definition of benchmarking, we can say that we are comparing the known quantity, that is produced vaccine doses. Produced vaccine doses is the known quantity with the actual reach. So we are benchmarking the actual reach for these produced doses of vaccine. That is, according to the definition of benchmarking, here we know the quality as well as the quantity of vaccines. Therefore, we are comparing it with the actual reach. This random dataset is given to the simulation test bed, which compares the estimated reach of vaccines with the actual reach. Or we can also compare the produced vaccine doses data with the actual reach of data. So this is all about the stochastic benchmarking of stochastic production planning in a simulation test bed. Thank you.